Welcome to Food Technology 1 FOT150S. I am Fosim Shaisa, and today we're going to start a new series on what I normally call mechanical separation techniques. And these techniques are basically used in the food industry in order to separate food components. These components can either be solid from liquid materials, or it can either be from solid to solid materials, or it can also be separation of immiscible liquids. Um, as a norm, we normally recognize people who are alive. So we see people like Olona, we see you, Sisanda, we see you, Bulelani, Hlonela, Lukolo, Yamkela, Duduzile, and Maposa. We note your presence in watching these videos, and we appreciate your questions, and we further encourage those that have not yet started to engage. Come, engage us via the WhatsApp group, or via questions on Blackboard, or via emails. If there's anything that we do not understand, feel free to ask. So, what are these separation techniques that I'm talking about? Already during the practical, when we were extracting the oil, we spoke briefly about centrifugation. So I hope this lecture will then highlight the importance of this technique in the food industry, or this technology in the food industry, and how we can then use it in various food applications. But most importantly, we need to have the underlying theory behind this technology, and what other machines or what other equipment can be used in the food industry. So, what will be the content of this presentation? Then we're going to look at basics like theory. Then we'll look at the separation of what we call immiscible liquids. Immiscible liquids are liquids that are not compatible, like water and oil. We'll look at the separation of insoluble solids from liquids. Insoluble solids, those solid particles that do not dissolve, and how do we then separate them? And dislodging is a new term. We'll then unpack what this term basically means, and then we look at the centrifugal filtration. Then we'll look at the equipment per each of these terms. So then we'll look at the application of centrifugal equipment in the food industry. So without further ado, what is the objective? So for you as a student, what is more important is that by the end of this presentation, or by the end of this course, or you should be able to define the terminology associated with centrifugation, and explain the underlying mechanism or the underlying principles of this technology. More importantly, I would like to bring your attention to the second bullet point. You need to be able to sketch or illustrate in order to explain the operation of the equipment used in the food industry, and discuss the applications of the various centrifugation methods in the food industry. You should be able now to say, if I have this type of product, what kind of a centrifuge can I use? You know, and why do I want to use this particular centrifuge? So, let us then start with the basics. What is centrifugation? Centrifugation is broadly defined as the unit operation involving the separation of materials by the application of centrifugal force. In this separation technique, the most important thing to note is that there is an application of the centrifugal force. Can I highlight my pointer here? Okay, there it is, laser pointer. Right, so the centrifugal force is what ensures that we are able to centrifuge the food products or the components. So how does this happen? So centrifugation subjects these dispersed particles to forces that are greater or exceeding gravity, which dramatically increases the rate of separation, and this is widely used for clarifying um, liquid food products. As we have seen when we had the oil, that if we separate the oil and we put it at room temperature for a week, then we can then have separation of the particles. However, that process is slow. Gravitational separation takes longer compared if we would use centrifugal separation or a centrifugal force. So where do we apply this principle? So this principle may be applied to the separation of immiscible liquids and the separation of insoluble liquids from insoluble solids from liquids. At this point, I would also like to bring to your attention that gravity separation, which is normally sedimentation, it's normally used in the cleaning of raw materials, as we have covered that in removing powders or dust from air and in separating solids from effluents. In this case, we are not talking about gravitational separation or gravity separation. We are mostly focusing on the centrifugal forces that are applied. So, what are the considered applications? We consider four applications, especially for this presentation. We look at separation of immiscible liquids, we look at separation of insoluble solids, removing solids from liquids, and we look at dislodging and the centrifugal filtration. So, if you visualize two immiscible liquids, it can be liquid A and B with different densities which are placed in a cylindrical bowl, and this bowl is rotated about the central axis. What will basically happen is that the more dense liquid, let's say for example liquid A, will move towards the wall of the bowl and will form then an annular ring in the inner surface. If we were to install what we call weirs or pipes at the outlet of the cylindrical bowl, the liquid can be fed into the bowl at a constant rate, and then the separation of the two immiscible liquids can be achieved. I know this is a lot of text, but let's look at it in terms of the diagram. So, if you've got two liquids, which is liquid A and liquid B, liquid A here, liquid B, assuming that this is a bowl wall, yeah, um, assuming that liquid B is the less dense liquid and liquid A is the denser liquid. So the denser liquid assembles towards the bowl of the bowl wall, right? It assembles here at the outward. And then the less dense liquid or the light liquid assembles in the center and it forms an annular ring because this thing is rotating at very high speed. And of course there will be an S space. But this diagram only applies, for example, in the smaller centrifuges that we normally use in the laboratories, like the one that we shown in the pilot plant. But now, in a larger scale, this is what can happen. So you can have sectional view. If we look at, for example, this will be your feed, the product that you feed in, and then this product goes in here. So this thing is rotating. So the lighter liquid will come towards the center and the denser liquid will come at close to the bowl wall. So this is both directions. But now if we can then install here a wear system whereby this now is separated, it goes to its own stream, right? It goes out here, which is the denser liquid, and the lighter liquid, which will then is separated. You see there's a line that separates these two liquids, so this one goes out in this side. So let me show you what we have done in the lab in terms of applying this technology. So we extracted oil from sunflower seeds using the oil press. So before extraction, after extraction, um this is how our oil look like. This is before we centrifuge the oil. And remember, I told you that in a centrifuge you need to always have equal number of test tubes, and then they should always be diagonal. As you can see here, there's two spaces, there's nothing here, there's no tubes, so I only had four tubes. And in this case I only had three tubes with oil, and then the fourth one I just added water. So this is a basically a laboratory or a lab-based centrifuge. So after centrifuge, this is what happens. Our oil is now clarified, and at the wall of the container, this is the black part that we get. And in this case, liquid, this black material, this will be the denser material, and then our oil will be the lighter material. In this case, we are looking for the oil, which is the lighter material. Then we can then decant um, this oil into another container, and then this darker material will remain in the oil. You can also see it clearly here in a smaller tube. So this is your oil over here, and then this is your components that are regarded as contaminants. Basically this is what is not needed. So this is the whole principle of centrifugation, is separation of these materials. So now that was the separation of immiscible liquids. So we can also use what we call the separation of insoluble solids from liquids. And if we talk of separation of insoluble solids from liquids, we talk of a term which is called centrifugal clarification. So some of you who have worked in the project for apple juice, you would have heard about the term clarification of the oil, of the juice. Basically is when you are removing the haze from the juice. So this term is defined as the removal then of small quantities, a few percent or less, maybe let's say 1% of insoluble solids from a liquid by centrifugal means. So you also apply centrifugation. So the equipment used for this purpose is normally operated on a batch principle. And if you look at the picture below here, you can see that we start with a juice that is more cloudy, almost like an orange juice in this case, and it contains these smaller things, we call them cells. So if you would subject that from a centrifuge, you can then be able at the end of the day to get a clear orange juice, which is almost like water or apple juice. So in this case, the solids with the greater density than that of the liquid will move towards the outer wall, while the less dense liquid moves towards the center. Right. So in all this case, you can then clarify your product or your orange juice. So if we talk of centrifugation, what basically happens is that as you centrifuge, as I've shown you on the previous picture on the lab centrifuge. So imagine if you've got bigger quantities, these separated solids then will build up in the centrifuge, and they have to be removed periodically. That is why our lab centrifuges, they work based on the batch principle. But now let's say we want to go to the food industry where there is big production. How can we do this? There is a term which we called dislodging or decanting. So this is defined as the removal of larger quantities of insoluble solids from a liquid by, again, centrifugal means. Right? So how do we then do this? So basically it's a continuous operation, but then we are able at certain intervals to remove solid materials from the liquid materials. So when the quantity of the solids present in your compound, in your product, exceeds that which can be handled by a simple clarifier, for example, if there's 5% or 6%, then we can then use what we call the dislodging or decanting centrifuges. And in the equipment that is used, provision has been made for the removal of solids at regular intervals. So we can then be able to remove these solid materials that accumulate at regular intervals. And a classical example that fits in here is what we call a conveyor belt centrifuge, right? So how does a conveyor belt centrifuge works? So the conveyor belt centrifuge, you've got your feed that comes in here, or which is your suspension, and then there is water that is also fed in here. So as these two materials or incoming materials come in here, the solid materials tend to be removed at the beginning, right? And then your product flows in here, it flows through these chambers, and then the liquid material appears at the end. So this is how we then achieve separation. So this technique causes the solids to be conveyed to one end of the centrifuge, whereas the liquid fraction moves to the other larger diameter end. So this is where your diameter, you can see here, it's a greater diameter compared to this area that is here. So the solids, which will be then relatively dry compared to other types of equipment, can be removed with this technique. So now we've talked about the separation of immiscible liquids, we've talked about the separation of the centrifugal clarification, and then we looked at desalging. Now we're going to look at what we call centrifugal filtration. So how does centrifugal filtration works? So basically, this is defined as the separation of solids from a liquid by filtration when the flow of the filtrate is induced by centrifugal means. So in this case, how do you achieve centrifugation? So you feed in your slurry into a rotating bowl with a perforated wall, right? So the wall is perforated, and then this wall is aligned with a suitable filter medium. So this wall that you have now contains a filter medium that can then separate these two components. So these solids that you have, they will be thrown against the perforated wall and form a filter cake through which the filtrate passes under the influence of a centrifugal force, right? And this technique is used in dewatering centrifuge, which is used to remove water from wet wheat. And how does it look like? So as well, here there is a filter. Okay, so you've got the feed coming in here. So if we look at this plane view, so you've got the feed coming in, and then here you'll have your liquid, and then there's a formation of filter cake here. So in between here, then this is where you will have your perforated bowl wall lined with a filter medium. Then your product comes out from this side. So if you look at this side, which is the plane, sorry, this is sectional view, and then this is a plane view. So you can see that this is perforated over around here, and then there's a filter medium that is aligned here. So this filter medium is lined here, and then obviously your liquid is going to, or your filtrate is going to go out on this other side. So what basically happens, then your feed comes in here, then there's a liquid over that is here, then there's a formation of a filter cake, and then there's a filter medium that is aligned here, and then the liquid comes out. And now what we're going to look at is the type of equipment that we can use in order to separate these components. And the first one, we look at what we call a disc bowl centrifuge. So this disc bowl centrifuge consists of a shallow white cylindrical bowl with a number of closely separated metal cones, and these metal cones are called discs now, which rotates with the bowl. So as the bowl rotates, also these metal cones or these discs, they also rotate, and they are located, what is interesting is that they are located above one another with a fixed gap or with a fixed clearance between them. So there's the spacing is fixed, so it's the same for every disc. right? So these discs, picture it's like, for example, if you've got donuts, right, and then you want to stack your donuts going up, so you will see, for example, all your donuts are the same shape, then it's the same size. They sort of create a hole, for example, how they do a kebab, like the kebab, that is the meat that is stacked, so there's a hole that is rotating inside. So basically these discs, they are also like that. So in this case, when this centrifuge is in operation, the dense material will flow towards the ball wall, down the undersides of the discs. Then the light phase will be displaced towards the center of the bowl and will flow on the upper sides of the discs. And these liquids are then divided into two separated thin layers, and these then can then be separated from each other. And then let's look at the diagram, how it looks like. So this is, if we look at this diagram on the left, so you've got your feed coming in. So these are gravity discs here. There's a stationary discharge covers, which basically separates, and then there's a rotating ball. So this is your ball that is rotating here, and then you also have the discs that are rotating. So this drive shaft is what holds the discs together, right? Is this, it goes in here on this disc, right? And then obviously this is your stationary casing. So basically how we then affect separation here is that the dense liquid comes out here on this stream, and then the lighter liquid will come on the other stream as this disc rotates. So if this is a plain view of the disc, how does the disc look like? It's almost like a CD, like a DVD, but it has got holes. So, and then as they rotate, all right, then the denser material is separated from the light material or the light liquid. So the denser liquid then comes out here, and then the light liquid comes out on the top. And basically the second one is what we call a conveyor bowl centrifuge. So same principle, you start up with the feed here. So your feed, which is a mixture of solid and liquid material. So the solid material will be discharged at the initial stage, and then the liquid material will be discharged at a later stage. And this is a rotating, so the solids then they line in the wall, whereas the liquid lines in the center, so then it comes out at the end. So it rotates slowly at a slightly slower speed than the the outer ball, sorry about that. And then the third machine that we find is what we call the tubular bowl centrifuge. So this type of centrifuge consists of a tall, narrow bowl rotating about the central axis inside the stationary casing. So basically, you have got a casing that houses the bowl, the bowl. So this bowl, they range from 10 centimeter to 15 centimeter with length and a diameter of ratios between 4 to 8. So the interesting part here is that the feed enters at the bottom of the bowl through a stationary pipe, and then this is accelerated to a ball speed by vanes or baffles. So the light and dense phases can also then leave via a wear system at the top of the bowl and flow into a stationary discharge cover. And how does this work? So Tumeleng, if you look here, so we start with the feed at the bottom, so it enters at the bottom part. So and then basically here, as the feed enters here, it enters into this bowl, right? And then this bowl is rotating, so the lighter part or the lighter layer comes into the center and it goes up here, and then because it's light, it will then filter on this side. So the green part is the heavier fraction, but the lighter fraction will then flow on this other side, right? So we can then be able to separate between these two things, and this is called a tubular bowl. And this is basically how the machine looks like in real life. So this is basically here where is the feed comes in and comes out here, and then on this side you've got the heavier fraction, and then on the other side you've got the lighter fraction. And now the question is, Now that we know all this information, how do we or where do we apply these in the food industry? So the tubular bowl centrifuges are applied at various stages of the refining of oils, and we can also apply tubular bowls in clarification of fruit juices, even clarification of sugar syrup from clear sweet manufacturer. And if we want to separate cream or skim milk from whole milk, we can then use what we call the disc bowl centrifuge. And if we want to also refine edible oils like what we've done in the pilot plant, we can also use a disc bowl centrifuge. But if we want to recover wine from fermented lees, we can then use solid liquid separators. Also, in brewing or in the production of beer, we can also use solid liquid separators. And if we want to separate products such as coffee and tea, then in that case we have to go for the decanting centrifuges, right? Because that process is a continuous process, and then you can be able to separate solid material from liquid materials. And last but not least, if we want to recover vegetable protein from potato slurries, then we have no option but to use filtering centrifugals. So centrifugal filtration. So this is basically your feed or your slurry comes in here. Then this is your liquid material. Then there's a cake that is formed, and there's a filter cloth here at the wall, and basically then this is your filtrate that you are looking for. So in summary, centrifugation is defined as the unit operation involving separation of materials by the application of centrifugal force. And then if we want to use centrifugal clarification, it's when we have insoluble solids. Note, when we have insoluble solids that we want to remove from a liquid, then we use centrifugal clarification. Centrifugal filtration, so the mechanism in that process, um, the mechanism of separation is filtration, and the flow of the filtrate is induced by centrifugal means. There are five types of centrifuges that we've spoke about. We looked at tabular bowl centrifuges, disc bowl centrifuges, solid liquid separators, decanting centrifuges, and filtering centrifuges. And all these you need to understand, and you need to know the application. Where is this these centrifuges, where can they be applied? So thank you for listening. So if you've got any questions,